So today we're going to look at the introduction to the electricity unit for our course. So remembering back from our chemistry unit that the structure of an atom consists of three different particles: electrons, protons, and neutrons. Electrons are found in the orbits or shells outside of the nucleus, and on this diagram here they are the green dots with the negative symbols. The protons and the neutrons on this diagram, being the blue and the red color, are always found in the nucleus. So the three parts of an atom consist of electrons, protons, and neutrons. So let's examine these objects. So object A and B are two different balls that are sitting side by side. Okay, you can see that they have a charge on them. So if we count how many charges this A has, they have 1, 2, 3, 4 negative charges and 1 positive charge. B has 1, 2, 3, 4 positive charges and 4 negative charges. So if we're looking at the charges overall, okay, you can see that the negative are representing the electrons and the positive are representing the protons on this object. So there's 4 electrons and 1 positive proton. So the overall charge on this ball will be negative. The ball number B, or letter B, has equal, okay, so they're going to be neutral. If we do the same thing for C and D, you can see that this C has an overall charge of a positive charge and D has an overall charge of a positive charge. All right, so in terms of laws and electric charges, there is a law of electric charges. It states that objects that have opposite charges will always attract to each other, and objects that have the same charge will repel each other, so they'll move farther apart from each other. The strength of the force is dependent on how close they are to each other and the amount of charge that is on that object. Okay, so closer objects or farther apart objects might have a different attraction or repulsion. So let's try this together now. We have a couple set of balls here. Okay, this first section here. If we count the positives and the negatives, you'll see that this is neutrally charged and this one is negatively charged. Are they going to attract or repel? They're two separate charges. They're not the same, so they are going to attract each other. Next, we have two positives. Two positives are the same charge, so they are going to repel each other. Next, we have a negative and a neutral. They are not the same charge, so they are going to attract. And then finally, we have two positives, and they are going to repel. All right. So looking at this diagram here, we have a couple of cases. We're going to look at case number 1 first. So these balloons are hanging from string that would have been attached to, let's say, a table. Okay. And you can see that balloon B, has a charge that is negative. So someone has rubbed it up against their hair or a piece of clothing and gave it a negative charge. Okay. We can see that A is attracted to B. Okay, so if it's attracted, it has a different charge than B. Okay, so A is either going to be positive or neutral. Okay, B, when it placed beside C, are repelling each other. To be repelled, you have to have the same charge. So C is going to be negatively charged. All right, case number 2. If you'd like it to take a moment, pause the video and see if you can figure it out. So for case number 2, again, we have a negative charge, okay, for B, okay. So if we figure out, okay, it's negative and it's attracting A, okay, so A has to have an opposite charge. So A could be positive or neutral, okay. If we look at A and C here, you'll see that they're repelling each other. So if A is positive, so will be C. And if A is neutral, so will be C. All right, so when we're talking about charging objects, there's a couple different ways that you can give a charge to an object. The very first one that you're probably very familiar with is friction. So rubbing two objects together, We can also transfer charge by contact, which is called conduction, and the last type is called induction. So we're going to look at charging by friction first, okay? So have you ever seen this electrostatic series before? Okay, so this is a diagram that would always be given to you on a test or a major assignment, okay? When you look at the electrostatic series, it has a list of materials under material right here, okay? If you take two materials on the list and you rub them together, one will tend to lose electrons and get a positive charge, and one will tend to gain electrons and become negatively charged. Okay, so when we're looking at two objects, let's say, for example, nylon and paper, nylon is closer to the top of the list, therefore it's going to get a positive charge and it's going to lose electrons. Okay, and our wool is going to, I forget our second one that we just used, sorry. Wool is closer to the bottom, so it's going to gain electrons and become negatively charged. Okay, so the electrostatic series is a diagram that helps us figure out what the charge will be when we rub two materials together. Okay, so static electricity, it's very important to mention that it means not moving. So we're not putting it through cords and using it as electricity. It's the build up of electricity on an object. Okay, so let's try this. I want you to pause the video and see if you can figure out what the charges would be on the silk and the balloon. All right, so silk is here and the balloon is down here. Because the balloon is closer to the bottom, it's going to gain electrons and become negatively charged. And the silk, because it's closer to the top when we compare it to the balloon, the position where the balloon is on the list, it is going to become positively charged and it is going to tend to lose electrons. Take a moment, pause the video, and see if you can figure out the next two. All right, comparing rabbit's fur up at the top and nylon. Nylon is right here. So rabbit's fur, if we compare it, it's at the more top of the diagram when we compare the two. It's going to have a positive charge and it's going to lose electrons. Nylon is closer to the bottom when we compare the two. It's going to have a negative charge and it's going to gain electrons. Ebonite and wool. Wool is closer to the top. It's going to have a positive charge and tend to lose electrons. Ebonite is closer to the bottom. It's going to have a negative charge and tend to gain electrons. All right, so I'm going to post this slide separately, but here are three little activities that you can do at home if you have a balloon or a ping pong ball and a cone to test out some static electricity just at your house. Now, if today is a rainy day in your house, I might suggest that you wait another day for it to be a little less humid because humidity affects your ability to do these experiments. I will post it again separately on D2L for you. All right, the next type of charging is charging by contact. So this happens when we actually touch two objects together, okay? We get this type of charge when we make contact between two objects and it charges it and it gives it a permanent charge. So if we look at this diagram here, we have a pith ball, and a pith ball is just a little piece of metal, often aluminum, that's hanging from a string, and it's often used in science in static electricity experiments. We also have a rod here. This could be an ebonite rod or a glass rod, and you can see that the positives and the negatives are represented here, so you can figure out, is it positive or negative to start? Okay, so right now I just counted them out and I can see that this rod is negative and this object, this pith ball, is actually neutral. Okay, if we bring the rod close to and actually touch, okay, the pith ball, the electrons that are in the negatively charged rod will move into the pith ball and it will give a negative charge to both the rod and to the pith ball, and they're going to start to repel each other. Okay, so electrons move from the rod into the pith ball. it made the pith ball negative. The rod was also negative. They now repel each other. Okay? So what if we start with a positive object? So we start with a positive rod and a neutral pith ball. Okay, so there's the same number of protons and electrons here. If we bring them close together, electrons will move out of the pith ball and into the rod. So the electrons are always going to move to where there is less electrons. Okay, and you'll notice that it's only the electrons that do the moving. Protons do not move. They are stuck in place. It's only the electrons. Okay. Once electrons move out of the pith ball, okay, the object will become positively charged. So that means both the pith ball and the rod are now positively charged, and they're going to repel each other because they are the same charge. Okay? All right. So an electroscope is used to show electrical charges, and I'll post a little video on what an electroscope actually looks like, but this is a quick little diagram. So we have a metal piece at the top, a metal bar that comes down, and then two pieces of gold leaf, or often there'll be some sort of metal, like you can do this with aluminum or tin foil, okay? And then a rod that's been charged up here, okay? So charging by induction, we're going to use the electroscope to show that. So charging by induction means that we charge an object, we bring it close to another object, but we do not touch. Okay, so there's no transfer of charge, just the movement of charge within that object. Okay, so here's an example. Okay, we're going to start with a negatively charged rod in A, and we're going to bring it close to the neutral charge of the pith ball. When we bring them close together but we do not touch, okay, electrons will actually move to the opposite side of the pith ball, away from the negative rod itself, and then we'll have a positive side close to the rod in the pith ball, and they'll be attracted to each other. Okay, once you remove that charge or that rod from close to the pith ball moves back to a neutral position. So the electrons move back and distribute where they were before.